All right, so based on our reading and learning about graphing and data tables, I want you to take a look at what I've set up here and try to finish this. So I've got a data set over on the left, you can see that here, and I've got a graph, and there's some stuff missing. And I've intentionally left out some stuff missing on the data table, and I've also left out some things on the graph as well. So see if you can complete the whole picture, and we'll come back and I'll show you some best practices and also some common mistakes that students make when representing data. Again, we're after high quality evidence here, and I want to help give you some practice for that. So pause, think, and see if you can make that happen. So hopefully you're able to complete it. First thing you should have noticed is that the data table is missing a title. So we'll go ahead and title that, and we can title it Vim and Zamble for a small toy car. Great. Notice we have no idea what Vim is. We have no idea what Zamble is. These are nonsense words, and I made them up on purpose to take the context away and to really help you see kind of just the general procedure of how to go from a data table to a graph and do it correctly every single time. You're going to need that because sometimes when learning physics, you still might be trying to understand a particular concept and not really understand the meaning of a word deeply quite yet, or at least not have mastered it. So you need to have skill at being able to work with graphs and the math of things, kind of independent from what the meaning of some of the variables might mean. So to continue, now let's look at the graph. Well, we do have a title on the graph, which is nice. Okay, so that looks good. Notice what we also have on the graph. We have the name of the variable, so in this case Vim down here, a symbol that represents the variable that would show up in an equation, and then the units of the variable. In this case, quandles is the unit for the variable Vim. Likewise, we have Zamble as a variable on the vertical axis. The symbol to represent Zamble is capital Z, and the unit for Zamble is in units of florbs. Cool. And I also have my graph axes labeled appropriately. I'm starting at 0, 0, and I'm on graph paper, and I have a set of numbers that makes sense. So now all we have to do is plot the points, and then if you did plot the points and you found a line of best fit, which we'll do in a second, I have a question for you. Were you able to also extract the relationship and find the slope and create an equation? I didn't explicitly ask that to you, but you should do that every time you make a graph. Try to find or do find the relationship for that graph. So pause, think, and actually try to do that correctly. Find the equation that represents the line. See if you can get it exactly right, and then I'll show you if you did. So here I've plotted my points, and notice that I've used point protectors. I've drawn circles right at the points where you can actually see the data. You should also be able to tell there's a little bit of scatter in our data. I kind of made that up when I made these numbers up just so you could see that it's not an exact perfect line, and you would absolutely never connect the dots on any type of graph like this. We're going to draw a line of best fit where the goal is to get half the points above the line, half the points below. On average, it won't work out perfectly like that every time, and when you do it with a computer, well, it does it for you. So I'll go ahead and draw that line of best fit now. All right, so there it is, and you can see half the points are approximately above, half the points are below. Maybe it's a little bit slightly off, but that's okay. I did that by hand. And now what I want to do is pick 2 points that are on the line. And you might think that, hey, can we just use the data points? Well, if you just inspect closely, you should see that none of the centers of these point protectors intersect the line. Maybe this one does up here, but I'm still going to choose a different point just for good practice, okay? So never make the mistake of just picking the data points in your data table. That is not correct. You have to pick points that are on the line of best fit. So in order to do that, I will find some points that make sense on my grid. I think right here looks like a good one, so I'll put a little cross there. So there's a point. And the coordinates of that point are, looks like 1.2 and 10. Okay, so I'll put that in parentheses right here, 1.2 comma 10. I'm going to leave the units off when I write things in parentheses like that just to keep it clear, but units are definitely important, as we'll see in just a second. All right, we'll keep going, and let's find another point. I'm going to go a lot further up, and this one looks pretty good all the way up here. Put a cross right there. Okay. So that's my next point. Let's figure out the coordinates on that one. So moving down, it looks like we've got about 6.4 and 52. So 6.4, comma 52. All right. Now, let you pause the video, and maybe you did this correctly before, maybe you didn't. I'd like you to, number one, find the slope of this line, and then number two, write down the equation that describes this line. Great test of understanding. Pause the video, see if you can do it. All right, so let's see how far you're able to get in this, and we will go ahead and calculate the slope. Just a quick refresher, it's just rise over run. So here's your rise vertically, and then your run horizontally. And that's just a change in the y quantity divided by a change in the x quantity here. That's what delta, this symbol delta or the triangle is. It's a change in, which is just a subtraction problem. Now, since we are in physics and not just kind of taking a general math class, we do need to use the appropriate variables. So up here, this is just kind of like the general math way to write things for slope. Let's turn this into specific variables for us. So on our vertical axis is something that is not y. It is, if I remember correctly, Zamble. So that would be capital Z. So we're going to have a change in Zamble, and then divided by the horizontal quantity, which is Vim, divided by a change in Vim. So this is going to be Z2 minus Z1 divided by V2 minus V1. All right, let's go ahead and plug those numbers in. And so Z2 is 52 minus Z1 of 10, all divided by, now V2 is 6.4 minus 1.2. But I've left a ton of space. Can you figure out why? Look at your paper and see if you have also left off some important information after each number. You likely did. A lot of students make this mistake. So pause the video and fill in what should go here, here, there, and there. See if you can get it right. All right, so you had to get those units in there correctly. I've abbreviated the units as well just to save a little bit of space. So the vertical axis had units of florbs, and remember the variable was Zamble. So there's these weird nonsense words, right? Okay, so 52 florbs minus 10 florbs for the change in Zamble, and we have 6.4 quandles minus 1.2 quandles for the change in Vim. Now we're ready to do the subtraction. So we come along and do that. So we've got 42 florbs divided by 5.2 quandles. And when you work that out, I'm going to round this. I think it's like 8.076923, something like that. So I'm going to round that to 8.1. So we'll just have two sig figs here. And this will be florbs per quandle. Great. See if you can say that like we learned in the previous video. How would you say this in words? 8 point what? Well, you could say florbs per quandle. 8.1 florbs per quandle. I don't want you to use the word per. Get some practice with this again. You can't use the word per. Say this out, write this out as a sentence. Go ahead, pause the video and try that. All right, well, hopefully you got it. There are 8.1 florbs for every one quandle. So now we've fully analyzed the graph with calculating the slope, but there is one more thing left to do, and it's to report the equation of this line. So how do we connect everything together correctly? Okay, this is the final step. I'll reveal the answer in just a second. Again, if you didn't get the final equation, or maybe your equation had the right slope value, but you maybe forgot your units, which is typically done. Check your equation, okay? And finalize your equation, pause the video, and we'll see it in just a second. All right, so we're back on our main page here with our data table, our graph, our line of best fit, our selected points. We're really looking at some high quality evidence now, a formal data table, and our very well done graph. Let's now finalize it by putting the extracted equation of this line of best fit right next to the graph here. So we'll write it, and what you would write would be the variable for the vertical axis first. So capital Z for Zamble. So that's a variable, not a unit. Now that's going to equal our slope value. We're just doing good old y is equal to mx plus b. I'll write that up here real quick. So a straight line from math class is this. In this case, b is 0, so there is no b value. So we have our y value that corresponds to z, or Zamble, is equal to our slope. We need our units, and it's actually 8.1. And our units of the slope were florbs over quandle. I'll use the abbreviated version there just to make it easy. I usually like to put that in parentheses to help me distinguish it from variables. And then we will take the horizontal variable, which would be the x variable in math class, but now in this particular context, it is a Vim, so capital V. So we'll go ahead and put that there, capital V. And now we have our equation. I'll put a little box around that. And this is our mathematical model that will describe for all time Vim and Zamble for a small toy car based on our high quality data set there. You could come along and plug in 20 Vim. I'm sorry, I said that incorrectly. Notice, right? You could come along and plug in a Vim value of 20 quandles. See, quandles is the unit. So I could come along and say, I have 20 quandles, and that would represent a certain Vim value, or Vim again is a variable. And then I would plug in, and I would be able to predict the number of florbs that I would get, and that would be the variable Zamble. So let's do that, just as a testing of our model. So Zamble is going to equal 8.1 florbs over quandle, and I'm going to multiply that by a particular value here of 20 quandles. And notice my units would cancel out. Quandles would cancel with quandles. And if I multiplied this out, 20 times 8.1 gives me 162. So let's write that out. All right. And that would be 162 florbs. That would be a little test of our model now. So we've predicted the future. If we had 20 quandles, we would now have correspondingly 162 florbs, and that would represent the particular variable that we're calling Zamble. Okay, so all of this nonsense is helpful because it takes away all of the contexts for you and really forces you to know if you're looking at a variable, a symbol, or a unit, and then work with these things. Now, in the physics world, what would you expect to see something like this? Well, maybe this could be distance. So instead of Zamble, it would be distance, lowercase d, and that would be measured in, say, meters. And then this axis here could be time, which would be lowercase t, and that would be measured in seconds. And then we might want to produce a model that would tell us how far we would travel in terms of distance, which would be measured in the units of meters for a certain amount of time, which would be measured in units of seconds. And we would have some slope value associated with that. And that would have units of meters divided by seconds, or meters per second, which would give us some indication of how fast we're going. All right, so there it is, an entire work through of producing high quality evidence for a controlled experiment. There is one thing we did leave off, and I'm not sure if you saw it from before. I forgot to mention it, but we did forget to put what constant values we had in our experiment. So down here, we could write below our data table constants, or variables held constant, and then we could articulate those here. I won't make things up now for brevity, but just remember that as well. Okay, so look at this video again as you study, and and for any labs we do in the future, or where you need to report high quality evidence. This is how you do it. All right, take care. See you in the next video.